Das haben wir uns verdient. Das haben wir uns verdient.
Welcome back. This is our third video. This time we're going to cover the do file, find out why it's the greatest thing in the world. So let's load our data. Assume you want to know the wages of union members, but also male union members. You want to calculate the covariance and the correlation between education and the wage, and maybe many things more. If you do that command by command and do something wrong, it's first hard to collect the data and have an overview of what you did. The second, if you have made a mistake, you have to go back and redo the whole thing, and that's very unfortunate once the jobs become a little bigger. What we can do here is we can work with a do file. A do file basically has all the commands you want to execute in there. It's just like a Word document, and it's this little envelope up here. So you click this and we have a do file. It's just an empty sheet of paper basically where you would write your commands. We always start out by saying clear, that clears the data in the memory. And then instead of manually loading the data, we can say use C student 76. That's where my data set is. And then we can start. We can start by summarizing the data. Let's keep it simple. Now this is our do file, and we can save this do file. So let's save it. And let's call it my metrics do file. Then we can execute this file. That doesn't mean we're going to kill it, it means we're going to run it. So, and that's this button here. We can do that without output too, but see, if I press this button, you see on the left hand side it executes all these commands. Right, I'm going to put it up here. So we see it says clear, it loads the data set, it summarizes the data set. Right? Now I can add some other stuff here. For instance, let's say, what is the wage of union members? We have a union variable in there that is 1 for union members and 0 for everybody else. So we can say sum wage if union member or unmem equals 1. That will give a mean wage of union members. If I also want the mean wage of male union members, I can do one of two things. I can say sum wage if union member equals 1 and male equals 1. Right? Another way of doing this would be to define another variable, just to have fun. You can generate a variable x that is equal to 0 for everybody. Then we can replace x equal to 1, so that tells us data that it should replace the values from 0 to 1 if male equals 1 and union member equals 1. Now this variable will be 1 only for male union members, and then we can say sum wage if x equals 1. So that it should achieve the same thing. Then we said we want the covariance and the correlation between wages. For the correlation we use CORR, education, wage. For the covariance we use education, wage, and then we say covariance, or just cov in the end. Alright, and then we wanted to find out, why don't we run this file now and see what happens. We run it and it executes all those commands. So we can go back here. Right, here we have clear, we use, we load the data set, we summarize the variable, we like the wage is about $10 an hour for everybody. We see that union members make $11 an hour, so slightly higher, and male union members even a tiny bit higher too. Then we generated the variable equal to 0, replaced it with 1, if male equaled 1 and union member equaled 1, and then we summarized the wage for people with x equals 1, which were the union members. We should get exactly the same as here. We see those two numbers are exactly the same. Then we correlated education and the wage. We see the correlation is a positive 0.43, so it's a fairly strong correlation. And the covariance is 639.22. Now the beauty of the do file is the following. If you made a mistake somewhere along the way, saying you reread your problem set and said, oh, Habermas didn't want the wage of union members, he wanted the ones covered by a union contract, the union cov variable. You would have to do a lot, potentially more, but if you have your do file, first of all you see everything you did, and you can just then say, well, then I'll just do it for union cov, and you can change your do file. In this example, of course, it's fairly simple to do that, but once things get a little bit more complex, the value of the do file goes up a lot. So, and then another very valuable feature of the do file is our problem sets will be treated in the way that you do things cumulative. So in one problem set you will create a real wage variable, in the next you're going to use this variable again. So by keeping a do file you don't have to redo all these commands. You save the do file, and then let's say you go out of STATA. Next time you start STATA, you bring your do file, you say open here, you open a do file, matrix do file, and instantly you can repeat what you did before. Bring your do file, you say open here, you open a do file, matrix do file, and instantly you can repeat what you did before. Now the next thing we want to learn about is a log file too. We see as the do file gets longer, the output here might not be visible anymore. At some point, STATA only stores that much. What we can do, we can start a log file who logs all our output. We can do that manually, here with a little scroll. We can do that manually and do a file, but we can also do that within the do file. So if I say log using, then I give the file name, let's say C colon backslash my log file, and then what I want to do is specify replace. We're going to do that for saving the data set too, because if you log this and you create this file once, the next time you execute the do file and that file already exists, STATA will not just automatically overwrite your do file. You need to say replace. Then at the end of the data say log close. Then if we execute it, we see we created a log file. Then we can view my log file and view the existing file, and it basically has everything in it that we did. We can read our output, and if you wanted to like print that out for a problem set, that would be fine too. So the log file is a nice thing too. Last but not least, when we alter our problem set and create new variables, let's say, let's create a new variable. Let's create the variable potential experience that we talked about in our lecture. So we say generate potential experience equal to age minus education minus 6. me see if we execute the log file, then say summarize, that now I have this potential experience variable.